Hello and welcome to the new episode of the Network and Cisco Packet Tracer tutorials for beginner. Siavash is here, and in today's tutorial we are going to work on HSRP on our routers. In previous video you've learned how to configure the HSRP, how to standby routing protocol for the core switches, multi-layer switches, and in today's tutorial we apply the same protocol for the router redundancy in our topology. So let's take a look in today's topology. We have a PC0 located on a network of 192.168.10.0/24 connected via this switch and between two routers R1 and R2, which act as active and standby routers in HSRP and act as a gateway for this network. So technically we set the physical IP address .2 on R1, .3 on R2, and our virtual IP address will be .1, which is gateway for network 192.168.10.0/24. We don't apply any specific configuration on this switch, just act as a connector between these three devices. And the other side, we have these two routers connected through the network of 13.0.0/24 and R2 via 23.0.0/24 to our internet. So technically, I use the same old techniques for a packet tracer, simulate the internet. Just put the normal router there, select it, and via here, just click as I create the new cluster. So packet tracer, change the icons to the cloud, and when you click on the cloud here, just we can see the router. Later we're going and set the just IP address, like let's put loopback IP like 8.8. I can type 8.8.8.8, which is simulate our internet connection here. We can go back and I'll just change the name to the internet. So let's begin with the configuration of our PC. It's very simple. Just go to PC. Here we go to the IP address 192.168.10.10 as usual /24 255.255.255.0, and the gateway will be our HSRP virtual IP address 192.168.10.1, and that's it for configuration on a PC. PC is ready to go. Very good. So switch 0, we don't have any configuration. Let's begin with R1 configuration. So let's go to CLI, press enter, go to enable mode and global configuration mode by conf-d, do show IP interface brief, and take a look what we have. So let's review this here. Click here, just hover your mouse over that. So gig 00 is connected to the switch on both sides. Perfect. So get back to the configuration. Interface gig 0/0. No shot. IP address 192.168.10.2. This is a physical IP address we set 255.255.255.0, and let's create our HSRP group. You learned on previous video about the details, but basically we just need to standby. Let's use the question mark and see what option we have here, and let's zoom it. So far we just set the IP address, physical IP address 10.2, and just standby, and the option we just need a group name, IP version 4 or version 6. That's act as a virtual IP. If we want to the device act as a preempt in case that the device R1 goes down, R2 become the primary or active device. If the R1 come up, it can take over the active role again. Set the priority. Default is 100, higher is better, and several timers, track, and versioning here. So standby, let's start with group 10. This just represent anything you like. Standby and IP 192.168.10.1. So here we go. Technically, with the simple command standby, group name, and virtual IP address, we enable that the HSRP on the interface level. If you remember, on the core switches, we applied the HSRP configuration on a SVI or a VLAN interface. But in the routers, we applied the HSRP configuration on a physical interface itself. So let's take a look, show IP interface brief, And yeah, just communication for HSRP already started. Since it's a single router or device in our HSRP group, automatically come from the speak to the standby. Couldn't find any other peer with higher priority, is claim the active role and become the active role. So show standby brief. The command can show us what's the current status. Let's take a look. We have a gig 00 is apply on this interface. The group of HSRP, default priority, and active, local, unknown. We still don't have any standby. And virtual IP addresses here. So let's, like a previous video, assign the active role to the R1. So we always like to be a control freak in our, as a network engineers, we want to have a control over our network. We don't want to leave to the default values. So just go to the interface gig 00 and just set the standby 10 and priority, let's increase to 150. So it's bit automatically 100. And now if I show standby brief, there is a slight difference here. We can see in this picture. Now the priority is 150. Previously was 100, which was the default value. Preempt didn't enable. We can do that, but it doesn't really matter here. And we can see the transition later. So let's do the same side, the LAN side on R2. Let's go to this one. And here we go. So let's enable this router. Go to global config mode, interface gig 00. IP address with 192.168.10.3, the physical IP address with the subnet mask /24, and no shots. So do show IP interface brief. We have the interface up and running. So we have a standby, same group, IP 192.168.10.1, same virtual IP address as we set on R1. So here we go. We leave the rest of the configuration, preempt and priority as a default. And here we go. So let's take a look. Show standby brief. And we have this configuration here we can compare. Enable on gigabit 0/0 interface, group 10, priority is default. In the status and the speak, still don't have any communication. And after a while, we can see what's change happening here. And here we go. So the communication between R1 and R2 is finished. Switch automatically state change from the speak to standby, and the reason is a priority is a default 100, and R1 we set the priority as a 150. So active is 192.168.10.2, the real physical address you can see here. Standby is a local, and virtual IP is same as we saw on R1, 10.1. Perfect. So R1 side is R1 and R2 side, and the LAN side we finish the configuration. Let's configure the WAN side of this. So we have R1, and let's go to global configuration. And we go to the interface gig 0/1, no shot. Interface come up. Let me double check which interface is that. Maybe I make it a gig 0/1. Okay, nice. Yes, correct. So IP address will be 13.00/24, just for sake of the lab. In real world, of course, you never get /24 IP address in the public side. And we just put the 1 and 3, so R1 and R3, but actually that's R6. Never mind. Let's go to R6, R1, and just put the IP address 13.001.255.255.255.0. No shot, just make sure. Do show IP interface brief. And here we go. So the configuration is done. Let's exit, put the IP route 000.000 to 13.00.3, which is we're going to configure on an internet router later. So let's take a look at the configuration. Very straightforward, nothing specific. By this level, if you follow the videos, you are master of this. Interface gig 0/1, IP address set, and just set the default route, which is IP route 000/0 to 13.00.3, which is our internet router. Let's do the same thing on R2, some simple configuration, 23. So we go to the global configuration, interface gig 0/1, no shot, IP address 23.002/24, and exit and set the IP route for a default route 000 to 23.00.3. Okay, perfect. Just let's do some host name if you want. There's R2. It's much more nicer. And let's take a look at the configuration. So we have interface gig 0/1. No, set the IP address, no shot, and set the default route here to 23.00.3, which is our internet simulator router. Let's go to R1, set the host name for this guy also, and final. Perfect. So we're good to go. And let's copy running to startup config. Perfect. Do the same configuration for R2, copy running to startup config. Perfect. So we have our configuration. And let's go to the internet router. This case is R6, doesn't matter. Enable conf t host name. I just put it R3. I don't like R6. So because we simulate R1 to R3 using network 13, R2 to R3 using network 23. So it's very easy to remember that. So let's go to the configuration and do show IP interface brief. I just connect that interfaces to 0/0 to the R1, 0/2 to R2. So let's begin. Interface gig 0/0, no shot, IP address 13.003.255.255.255.0/24, interface gig 0/1, no shot, IP address 23.003.255.255.255.0. Do show IP interface brief. Here we go. So everything is in place. 0/1, IP address 13.0.3 and 23.3. So very good. Here we go. So and let's configure one loopback, which is interface loopback 0. And IP address will be 8.8.8 with the /32. Okay, perfect. So show IP interface brief. It can be /24 also, but that's good. So we just go to the interface loopback 0 and just IP address. Set the IP address which act as simulate our internet communication. Perfect. So we're done here. Let's go back to the here and do some ping tests from R1. Okay, interface R came up. Let's ping 8.8.8 and see can we ping it or not. Nice. Ping is up and running. So we have an internet access technically from R1. Let's do the same ping test. Ping 8888, and here we go. After the first broadcast lost, we have a full connectivity to our internet. So R1 and R2. So in real world scenario, these are act as our ISP routers. They're connected dual ISP we have, and they connected to the internet, and we have our PC need to communicate with the outside world. So technically, let's do some basic tests before we test the internet because need additional configuration. Let's ping our virtual gateway 192.168.10.1 and see can we ping the virtual IP gateway, which is correct. So we can go outside, but still we couldn't ping the outside world. And I'm sure you know the answer now because we discover and learn about this on our NAT video. So we need the NAT. Technically, in the real world internet, don't have any idea about inside of your network IP address setting. So R1 and R2, we need to configure the NAT over that. So just in case that is any communication want to happen from inside of network, go through the NAT and just communicate with the outside world. So let's do the quick NAT configuration. This is a recap, so it's a complete video. So you can just follow this configuration and have a complete communication end-to-end. So R1 interface gig 0/0. Let's start with the inside. So it's IP NAT inside. Just that's it. This configuration. interface gig 0/1, which is our WAN interface. Just IPNet outside. Here we go. Let's take a quick look. IPNet inside for gig 0/0, and interface net IPNet outside for our WAN interface, which is interface gig 0/1. So now we need to create the access list for our NAT. So let's create IP access list and use a question mark. We just create the standard one. We just need from just let's call it just LAN, and that's it. And just permit 192.168.10.0 network, and using the wildcard mask of 0.0.0255. So let's take a look at our access list here. Here we go. So we have IP access list, just standard one, put the name, call it LAN, and we allow that 192.168.10.0/24 allow on this network. And now it's time to configure the NAT. So IPNet inside, that's a command with source. Just use the question mark. You just become familiar with, if you no need to remember this command really, just anytime you can use the question mark, and this help on iOS help you to remember the command. So we use IPNet inside from the source, and we're using the list. We call it LAN, and we're just using the outside interface, which is interface gig 0/1, and we need the overload. So this is our full command for NAT apply. So IPNet is a command using inside NAT, using the source list, which we create our access list just here, IP address list, and are going out from our interface gig 0/1, and using the path means that the overload helping to the apply. If you forget this concept, just revert back to our previous video regarding our dynamic NAT. And here we go. So technically the NAT on this side is just getting done. Just copy running to start up, just in case, because we want to shut down this router and show that simulation of how the HSRP act. Let's do the same configuration on R2. So technically just you can copy paste the same configuration from R1 and put it here, but let's do it. Conf T interface gig 0/z IPNet inside interface gig 0/1 IPNet outside exit. So we have an IP access list, just use it as a standard one. Oops, and just can name any name, we call it NAT, and the permit 192.168.10.0/24. Here we go. Here, as you can see, the same configuration. We just create the IP access list, call it NAT, and permit the 192.168.10.0/24 network here. Exit IPNet inside source list, and we call it NAT question mark. We're using the interface for exit 0/1 and overload. Simple as that. So now you know how the NAT works. Easily you can configure everything. IPNet inside from the source list NAT. Go to root this interface, and using the overload for path, so multiple devices can go out. So technically everything should work as we expecting. So what we did, we configured the HSRP, put the virtual IP address using the command standby on interface level, set the, of course, physical IP address, then just put the default route to our internet and set the NAT. So let's go to the PC and see, can we ping the outside world or not? Here we go. So our ping is immediately up and running. So trace route, I don't know, trace it, how does it work? Trace it, trace 8888, okay, trace route 8888, trace cert, sorry, I forgot the command. Oh, here we go, trace cert 8888, and we choose our main active routers here. As you can see here, we choose the R1, so 192.168.10.2 hit, then go through the internet and hit the outside world. So means that our NAT is working fine. So now let's some ping test. Ping dash T. I'm not sure that's how this works, but let's see what's the behavior of our standby. So let's do the one by one. So we can go out from this PC. We are sure that we can ping from PC0 to the internet. Now let's go to the R1, make sure the configuration is done, go to the physical and just click on this switch. Turn off, router went down. So let's take a look from the R2 perspective. So the default timer for HSRP is 10 seconds. After 10 seconds, or 3 times 3, so just realize that that's timer. And you see this router is immediately claimed that himself as active because couldn't see the other side. So now go to the PC and we run the ping test. We're expecting to able to go out from this router also. So let's see what's the behavior of standby, and if we make any wrong configuration we can troubleshooting, but it looks like our ping came up immediately and we don't have any issues. So you can see that's how the redundancy really work in real life. Our R1 is totally down. The configuration by HSRP help us to our gateways automatically switch over on a second routers, which is our standby. And if we take a look at the trace route now, I'm using the up arrow to avoid any misconfiguration, and this time we can see that how the PC goes out. It hit our R2 10.3 and hit the internet. So as you can see, this is nicely is a redundant plan. Here we go. And let's turn on and do some testing. Let's turn it on and see how it looks like. The configuration is booting up. So this time I would just want to test something to see the session of the NAT remaining on R1 or not. Let's take a look. Show standby brief. Okay, so it's in a speak state. Try to identify. In the meanwhile, let me go to the interface gig 0/0 and just put standby. Okay, technically this is automatically preempt the situation. Never mind. And look here, show standby brief. Here we go. So this is active. Priority is higher, so it's take the ownership of that. If you go here and use a trace route, you can see how it goes out. Just wait a moment, because the gateway technically switch over to 10.2. As we can see, it's beautifully it just switch over. You can compare these two nicely. So this is when the R1 was down, so R2 take care, and when R1 came up, R1 take care of the virtual gateway. Now let's do this continuous ping test. I'm going to ping the 8888, which is our internet, and at the same time turn off the internet. So here we go. We have this one. Oh, okay, it's okay. Let's switch. R1 turn off, and here we go. See what will be happen here. Okay, we have request timeout, and let's see. There's a ping comes up after a while. Yeah, and you can see this is even automatically. But of course, you know, on a PC0, if you browse something, might lose the substation. But that's okay for TCP. Just it can immediately detect that's R2 and can communicate. So I hope this video is informative for you and you learned something new. And please, as usual, subscribe to our channel, watch, learn, show our channel to your friends and colleagues. And thank you very much. See you soon in the new video.